Hello everybody, and welcome to today's session of Learn Extra Exam Revision. Today's topic is maps and GIS in geography. Before we get into our maps and GIS, and before we actually take a look at a past paper to give you an idea of how your examiner might ask some questions about it, we need to have an understanding of our revision and to know what it is that is a GIS and how we can use it in the real world. Let's take a look at our checklist. Make sure that you know how to, first of all, describe what a GIS is. Now, a GIS stands for Geographic Information System. Essentially, we're talking about an interaction between humans, computers, databases, satellites, and anything else that can give us information about maps in a real-time experience. That is, at the flick of a button, from your cell phone to your computer. We'll take a look at how this all fits together in a diagram just now. You also need to be able to explain the different types of data involved. Now, data, very simply, is information. Information in your computer that can be used by a human to make decisions. And that data goes from everything to the structure of the Earth all the way through to bits and pieces and buildings and roads and railways and things on the Earth, all put together. In addition, we need to understand how the GIS and its information inside can be used to solve problems. Because essentially what this GIS is, it's a decision-making tool. It's a tool used by humans to be able to make our lives easier. Let's take a look at the structure of the GIS, and you'll see how it feeds into helping us out in making those decisions. We've got our little friend here who's wanting to make decisions about GIS. Things like, what's the quickest route to the shops? What's the best route for me to travel on in order to get to my holiday destination? Which hotels are overlooking the beachfront? These are all questions that can be answered by a GIS. It's simply about asking the right questions. So our little person is going to interact with a number of different devices. This can be anything from a cell phone, the little GPS unit in the motor car, and even, of course, your desktop PC or tablet. Any one of these devices can be used by a person to access primarily the internet in order to get a hold of the information that we need to make those decisions count. So from here, these devices are going to connect up to a database. Now, a database, very simply, is a place where we can store information. And the storing of that information comes from a variety of different devices, from satellites, which take photographs of the Earth from space, from GPS units, so a person running around in the streets with a GPS unit, punching in coordinates to say that this is where they're standing, aerial photography, photos taken from aeroplanes in order to see what the world is like, to be able to place those elements in context, in positions. And of course, all of this will be put together with our coordinates of latitude and longitude. Now, all of that together winds up in our database, as we've said, including our friends latitude and longitude. And that database then is the storage facility for all of this information. Thereafter, it's a case of your cell phone, your tablet, your PC, accessing the data through a program like Google Earth or ArcView GIS or any of the other programs that are available to you. And using that interface, using that program, the human can get the information, ask the question they need answered, and get the answer back from that GIS that has interrogated the database in order to find that information. So it's a vast piece of information, it's a vast system, and it's available to everybody because if you think about it, you as a human being can access the internet, you can upload photographs, you can upload information to the internet which would go into your database. That then would be available to anybody else who wants to be able to use that photograph, that GPS coordinate, that route that you took to get on holiday. As part of the data, you're also talking about not just the digital stuff, the latitude and the longitude, the points, the lines, the polygons, which we'll get to just now, about actually drawing in the shapes and the boundaries of all the different features that go into the database. We're also talking about data that describes what's going on in those places. This is referred to sometimes as attribute data. It gives the characteristics of the thing that you're putting into it. So in some cases, you might have gone on holiday, stayed at a particular hotel, had a wonderful time, and you write up a review about your holiday. In doing so, you have just created a little bit of extra information about that place, which the next user can use. So it becomes a very much an interactive system between users and the database, with the computer in between being able to provide the access for the two. Now that we've got a bit of an understanding of that, let's take a look at some of our questions that an examiner might give to you to ask of your knowledge of a GIS. Because as we can see, this is quite a big picture. It's got a lot of nitty-gritties, lots of information, and there are various parts of that information that would be asked in different ways. Let's go to the next page and take a look at some questions, some examples, so we can get a more practical point of view of using a GIS and a map. Question 1 says, 1.1, study the map below which shows the path of the tornado that tore through Harrismith a few years ago. Many data layers were used to draw this map. Let's look at the map in a bit more detail. So what we have on this particular diagram, on this map, is a number of different things. Up here we have a hill, as indicated by the contour lines. Over here we've got a road, the National 3 Highway. We have a farm and an airfield. We have a dam, a body of water. And then we have the path of the tornado, which is indicated by that dotted line there. Now, what we have here is a whole bunch of information that's been shown to us in a visual form. And the beauty of it is that we have got a computer that has put all that information together, making it easier for us to access. So first up, we need to ask the question, what is the story about these data layers that's important to us? Data, remember, is information. So it's information about the landscape of this map. The layers simply provide the interface or the way in which we see the map. It's kind of like taking a whole bunch of overhead transparencies, those plastic sheets, and putting a different piece of information onto each one. Then when you put all of them together, a pile of them of maybe 5 to 10, and you looked at each one, each plastic sheet having a different piece of information, if you were to flip it up and look through it, you would just see one picture. Those different layers all give us the different pieces of information, but we can see it all on one picture by looking at it through the computer. So in terms of our data layers, let's go back and take a look quickly at our map. Our data layers would include things like elevation, height above sea level. These contour lines here each have their own pieces of information telling the user or telling the computer where they are on this map. There's another layer for transport that would include the National 3 Highway and the position of the airfield. We might have another piece of information telling us another layer about aquatic features. So the dam would be on a different layering system. And finally, we might have a piece of data or layer that is showing us or plotting it for us the path of the tornado. Now, if each one of these colors was a different data layer, we would see each one of them on a separate sheet of plastic. Put them all together, you've got your GIS interface. And so our examiners asked us, define the term data layering. Now that's got to do with that idea of taking different pieces of information, stacking them one on top of the other. So it's a combination of different data layers, different pieces of information, to produce a map for a particular area. Further from there, 1.1.2, name 2 data layers visible on the map. If we were to go back to that map, remember, we found things like elevation, aquatic features, transport. Let's go down and check our memo. And we can see here the road, airfield, or transport infrastructure. That would be one layer. Relief or contours or elevation. Another word for all of that is topography. The aquatic features, the dam or the drainage of any rivers. Farming and cultivation or human activities, that would be another layer. Any buildings the humans have built in the area would be another layer. And finally, the path of the tornado. Question 1.3. GIS is useful in disaster management. Explain how it would have assisted the local authorities with planning after the tornado had struck. Remember we said at the beginning of the session that a GIS is a decision-making tool. It helps people make decisions in a spatial environment. And what we mean by that is it helps us to make decisions about which routes to take, which areas to go to. These are the things that we would then apply to a disaster situation. So we're looking at things like, well, which areas have been affected by the tornado? Which transport routes are the quickest to get there to help people? Where are the nearest hospitals and how many are there? These are all pieces of information that we can ask our GIS to give us so that we can make the best possible, fastest decisions to help the people affected by the tornado. So we could check things like service delivery shortfalls. That would be things like access to water, access to electricity and communications, taking away of waste materials, supplying the survivors with food and with medical care, that sort of thing. Route planning to supply relief. What's the best route to take? What's the quickest route? The easiest route to get into that area. We'd be able to analyze the quality of service that's being provided. We'd be able to coordinate the different relief services. So you'd have a central decision-making body and then different services making decisions or taking orders from that decision-making body based on the data that's been supplied to them by the GIS. We would prioritize relief. Who needs the help the most urgently? We need to get to those guys first. And the satellite pictures that we would access via the GIS would be able to show us exactly which areas have been affected by the tornado, and so we can focus our efforts on those. Question 1.2 says, study the photograph below of the National 3, the N3, that bypasses Harrismith and connects Durban and Johannesburg. Now, if they're giving you a photograph like this, they're going to be asking you about information that the photograph supplies. So let's just take a look inside the photograph and see what it is that we can see. So in this photograph, we can see that it's been taken from the viewpoint of somebody in the motor car. There's a GPS unit over here. You can see the speed dials and the rev counter. And in front of us, we have got a nice big truck traveling in the same direction that we're traveling in. And we can see some oncoming traffic in the other direction. So this is a multi-lane highway, as they've said, between Durban and Johannesburg. We can see that it's quite broad, and at this stage we can see that it's fairly quiet on this particular day, but the fact that we've got this big truck on it, I think, suggests that this is quite a busy route. Let's take a look at our questions. 1.2.1 asks us to differentiate between spatial data and attribute data. Now, that's quite simple. Spatial data is the data that tells us where something is. So where exactly, the route of the National 3 highway, the route a river follows, the position of a building, the position of a tree. That's all spatial data. Attribute data is the information that tells us more about that particular feature. So it tells us more about the highway, more about the river. If we're looking at a river, it could be things like the discharge of the river. Is it a perennial river? Is it a periodic river? Those sorts of things. So attribute data is information about the feature. Spatial data tells us where to find that feature. So in the words of our memo, spatial data describes the location of features using coordinates, latitude and longitude, or position of features. Attribute data is the value given to the spatial data or characteristics about that feature, or in other words, a description of the feature itself. So looking at our data, they then ask you what type of spatial object, and here we need to get specific, point, line, or polygon is the road. Now remember, in your GIS, in that database, the information about the different geographic features is stored digitally. So we convert it into numbers. And there are 3 types of data that would describe or position a particular point in space. Those are a point, a line, or a polygon. Now, very simply, a point is a single place, like a tree, a signpost. A line, like one that you've just drawn, is a linear feature, a feature that extends in a particular direction, like a road or a river. And a polygon is a closed geometric shape. Any closed geometric shape that would be used for drawing things like fields, buildings, lakes and dams, anything like that. So those are our 3 kinds of features. Now we have to ask ourselves, or the examiner asks, what type of spatial object is the road, a point, a line, or a polygon? I think this one's going to be fairly straightforward. Naturally, it's the line. And then they ask us to give one attribute that can be captured for the N3. So they want us to describe or get a bit more information about the N3, and maybe it would be useful to go back to the photograph then, and we can see what is it about the National 3? What more can we use to describe it? And here we could use things like, well, what kind of road is it? We can see that it is a tarmac road. It's not a dirt road. We can see that it's got multiple lanes. We've got 2 in each direction on this particular case. And the fact that it is the N3 or National 3 tells us that it is a main highway. That is what we mean by attribute data. And those are the answers that we could use to answer this question. So here we go. It's a national road, it's a tarred road, there are many lanes, the lanes are marked with paint, so we've got arrows and solid lines and dashed lines. There are benchmarks, those are those little concrete pylons you sometimes see on the side of the road, showing you the altitude or height above sea level of the road at that point. Road signs would be visible, so how fast you're allowed to go, warning signs, etc. And then of course everybody's favorite, the speed cameras. Where would you find them on the road? A lot of your GPS units tell you where to find those speed cameras in order to help you keep out of trouble. Let's take a look at our next question. 1.3. If a vehicle with a global positioning system or GPS approaches Harry Smith, how can the GPS assist the driver to find the hospital numbered 10 on the orthophoto map? So what they're saying to you is, you're traveling with an orthophoto map and you're trying to find the hospital. How does a GPS help you to do that? Now, if you think about it, those little GPS units in your motor cars that just about everybody's got these days, they can be programmed, as you know, to help you to find your particular route. And it's all about distance and direction. So what you could do is you could say to your GPS, I want to go to that hospital, help me to find it. And the GPS, by accessing the data through the satellites, is going to say, right, keep going for 100 meters, turn left, travel for 50 meters, turn right, and so on. And here it is. It will provide your precise position and direction where you are now and where your destination is, and then guide you along the roads to get to that destination through your navigation system. Okay, that brings us then to the end of question 1. Let's take a break and we'll see you in a little bit. And welcome back to you. Let's start with question 2. Study the bar graph below, which depicts temperature and rainfall data for Harrismith. A statistical analysis of the data on the graph will be useful for farmers. The bar graph is an example of attribute data. Let's take a look at the graph itself. Okay, some interesting things that are worth noting. First up, we can see that we have got temperature up this axis. We've got rainfall up the other axis, and we've got the months of the year across the bottom. So we're talking about a relationship between 3 things: time, rainfall, and degrees Celsius or temperature. So they've asked us again, what is attribute data? Remember, it's descriptive data. So attribute data refers to the descriptive properties of objects, events, or features. It's information. It describes the information itself. Question 2.2. Give one attribute that is provided by the bar graph. Well, very straightforward. If you look at the bar graph, you're looking at rainfall or temperature. That's the information that's coming across out of the graph. So those are our attributes or characteristics that we're dealing with: temperature and rainfall. And then question 2.3 says, explain how you can use the attributes provided by the bar graph. Well, if you go back to the graph, what information is being given to us? We're going to be seeing things like how much rain or how high the temperatures are across the year, at which season, for example, you might be getting your maximum and minimum rainfall, winter and summer and so on, times of the year. You could actually, if you had the time, add up every piece of information in terms of total rainfall. You could work out average rainfall, average temperature, your temperature range. These are all different pieces of information that all come out of your graph like this, determining the average temperature or rainfall, the maximum temperature or rainfall, the minimum temperature or rainfall. We can determine which months have got a high temperature, which months have got a high rainfall, and of course vice versa, the low temperature and the low rainfall as well. And that's all just gathered from a piece of information that's expressed visually in a bar graph. Question number 3. Remember what we said about GIS. GIS is a decision-making tool. It's a whole bunch of information stored in your database that you access through the computer to make decisions. Here they're asking you to make a decision. They're saying, how can GIS assist city planners to determine where a new shopping centre can be built in Harrismith? So your city planners then are going to be looking for open space in order to construct this shopping centre, but in order to do that, they've also got to be able to find where their customers are from. So it's pointless putting a shopping centre way out in the middle of nowhere, because the customers that they want to attract are not going to be able to access them. So they need to have open space. They need to ask the GIS, where are the main transport routes that will bring our customers to us? They're also going to ask you things like, well, where do we find the people with money? Where can we find those residential areas where people have got a higher income, because we want to make more money out of them? So it's a question of profitability. So all of these kind of questions are the ones that a GIS can answer by supplying you with the information about, here's where the roads are, here's where the open space is, here's where the flat ground is, here's where the middle income, high income, low income people are, here's where your customers are. These are all your different answers that your GIS is going to give to you. So the GIS would be used to allow the people to locate the suitable area where it can be built. It can be used to determine profitability, whether they're going to make more money by putting it in this area on the right, or this area on the left, or at the bottom of a hill, whatever the case is. And we would do that by looking at the income bracket of the people in the surrounding area. In addition, it would determine which routes, which transport routes are going to be used by the people to access that shopping centre. Question number 4. This is a map question, so you would find this on your orthophoto map in this case. Now remember, an orthophoto map is a combination of a map and a vertical aerial photograph. It's a picture where you have got, and let's just scroll down and we'll find an example of one. It's a photograph where you've been given contour lines as well. So here's some examples of contour lines, but you've also got labels like spot heights, like you would expect to find on a topographic map. So by taking a topographic map and a photograph and putting them together, we've got a lot more information. We can actually see what the feature looks like in reality by looking at the photograph part, but we've also got information about elevation from the labels that are traditionally associated with a topographic map. So let's just remember that and then get into our questions. So the question asks you to draw a cross-section of the feature from 2 to 3 on the axes below. So let's go down to the map again and take a look at our feature. So they've marked off 2 and 3 for us. They've put in a line in between to indicate where they want the cross-section. And don't forget, a cross-section is a profile. It's a side view of this particular feature. Now looking at the map, the orthophoto map, you're looking down on it like the aircraft that's taken the particular photograph. What they're asking you to do is to take that viewpoint and flip it up on its side so that they can see the hill viewed from the side as a profile. So how would we do that? Well, first of all, we have to take a look at the question very carefully. And they've said to us, draw from 2 to 3. What you need to do, guys, is to make sure that the number 2, or the starting point there, is on your left-hand side. So in effect, you'd be turning this map around in order to look at it. So your right-hand side would be where number 3 is. So you're going to be looking at the feature from there. What you would then do is take a piece of paper, stick it along this particular line that they've drawn between the 2, and then on your piece of paper, mark off every single contour line, and I'm going to change colors for this so that you can see it more clearly. I'll use green. We're going to mark off every single contour line where it crosses that straight line that we marked with a ruler between 2 and 3. Once you've done that, you would then take that piece of paper and apply it to your axes so that you can take the positions, because that's what you've done. You've just plotted the position of each contour line, where it occurs between 2 and 3. Now we need to put it onto the axes so we can plot it vertically so that we can see the height of each contour line in a visual space. So what does that mean? We're going to take the heights, and what is really great is that they've marked it for us. So for example, you can see here that this particular line, which goes around here, has been marked 1700. This particular line, we can see here, is 5 meters higher because we're on an orthophoto map. Remember, the contour interval, the difference in height between each line is 5 meters. So this one is going to be 1705. There's spot height 1706. This line here is also 1705. So in actual fact, they are linked. So what we would then do is take that piece of paper, once we've marked off all the different lines, take it back to our map, our axes that they've given to us, and start to plot them with position number 2 there. Position number 3 would be out here somewhere. And now it's simply a case of plotting the horizontal position of each line with its matching height that they've given to us. So if we refer back to our map quickly, position 2 is at 1700. So position 2, we would start here. There it is. A little bit further in, the next line was 1705, so it would be there. The third one was 1705, and so on all the way to the end. Once you've finished, it's simply a case of drawing freehand, no rulers, because you never find perfectly straight lines in nature. go freehand through each dot to connect it up. Something like this. And so on all the way to the end. And it's as simple as that. Let's take a look at the final solution here. And there we can see taking care to plot every single place, every single contour line in its exact position, and then just to draw it up freehand by going through each of the dots. Drop in a vertical at the end, use a ruler, make it neat and tidy, and then if they haven't done it for you already, don't forget to put in your headings, your horizontal scale down the bottom here, which is the scale of the map or orthophoto map, your vertical scale here, which in this case they've given to you, 1 centimeter represents 10 meters, and then it's also quite a good idea to write a heading. So in this case you might say cross section or CS from 2 to 3, and then just underline it neatly using a ruler, and A for away, you're sorted. Our final question for today has asked us to calculate the vertical exaggeration of the cross section above. Now first up, what is vertical exaggeration? Let's take a look at our map again, at our cross section profile again. We've got two different scales here. We've got a horizontal scale here down the bottom, which, as I've said, is the scale of the topographic map, or in this case, the orthophoto map. 1 is to 10,000. That means that 1 centimeter on the map represents 10,000 real centimeters out in the landscape. Our vertical scale here is different. We've got 1 centimeter represents 10 meters. Now, the reason that we do this is so that we can get a better picture of what the hill or feature looks like. If we were to plot a cross-section on exactly the same vertical and horizontal scales, you would find that your profile would be very flat. But by exaggerating the vertical scale, it means that we can actually get a better idea of what that profile looks like. Now, the last thing that your examiner wants to know is, how much bigger have we exaggerated the vertical scale? It's a fairly simple little process and a very simple little calculation. Here we go. Vertical exaggeration, or VE, is calculated by placing the vertical scale over the horizontal scale and then performing a normal maths calculation. So how do we do that? Let's take a look. Our vertical scale, remember, was 1 centimeter represents 10 meters. No problem there. And our horizontal scale was 1 is to 10,000. Again, no problem, until we look at the whole picture. And we see that at the bottom, our horizontal scale, both the 1 and the 10,000 are in the same units, no problem. But at the top, we've got 1 centimeter represents 10 meters. This here is a little bit of a problem, and we want to eliminate it quickly. So what we need to do is we need to convert these 10 meters into centimeters so that everything on this fraction is in the same units of measurement. So very straightforward. What we do is we quickly work out how many centimeters are in a meter. That's 100, so we add on 2 zeros. So that would mean that our vertical scale is now 1 is to 1,000 by adding on the 2 zeros, over the horizontal scale, which hasn't changed, 1 is to 10,000. And now it's off to normal maths, except what we've got here is a ratio over a ratio. Now, for somebody who's never particularly strong at maths like myself, you want to make this as simple as possible. A ratio is a fraction. If we convert these two ratios into fractions, it's going to be a lot easier. Let's take a look. So what I'm saying is 1 over 1,000, that's just the ratio stuck on its side, over 1 over 10,000. Now it's going to be easy to work with. Now immediately I look at it and you say, well, actually is that easy to work with. It's an ugly fraction. We've got a fraction over a fraction. This is where you get the easy stuff in, the tip and times method. So it's the same as 1 over 1,000 times by 10,000 over 1. Straightforward cancelling out here. Knock off 3 zeros there. Means I can knock off 3 zeros there. That leaves me with 10 over 1, which of course is 10. What that means is our vertical exaggeration, our vertical scale, is 10 times larger than our horizontal scale. And that's what we've done to create it and make it bigger so that we can see it more clearly. Straightforward. There's our final solution. Wishing you every bit of success with your exam that's coming up. That's all for today. Take care. Cheers. Is information. Information in your computer that can be used by a human to make decisions. And that data goes from everything to the structure of the earth all the way through to bits and pieces and buildings and roads and railways and things on the earth all put together. In addition, we need to understand how the GIS and its information inside can be used to solve problems. Because essentially what this GIS is, it's a decision-making tool. It's a tool used by humans to be able to make our lives easier. Let's take a look at the structure of the GIS, and you'll see how. Make sure that you know how to, first of all, describe what a GIS is. Now, GIS stands for Geographic Information System. Essentially, we're talking about an interaction between humans, computers, databases, satellites, and anything else that can give us information about maps in a real-time experience. That is, at the flick of a button, from your cell phone to your computer. We'll take a look at how this all fits together in a diagram just now. You also need to be able to explain the different types of data involved. Now, data, very simple, and even, of course, your desktop PC or tablet. Any one of these devices can be used by a person to access primarily the internet in order to get a hold of the information that we need to make those decisions count. So from here, these devices are going to connect up to a database. Now, a database, very simply, is a place where we can store information. And the storing of that information comes from a variety of different devices, from satellites, which take photographs. It feeds into helping us out in making those decisions. We've got our little friend here who's wanting to make decisions about GIS. Things like, what's the quickest route to the shops? What's the best route for me to travel on in order to get to my holiday destination? Which hotels are overlooking the beachfront? These are all questions that can be answered by a GIS. It's simply about asking the right questions. So our little person is going to interact with a number of different devices. This can be anything from a cell phone, the little GPS unit in the motor car, hello everybody, and welcome to today's session of Learn Extra Exam Revision. Today's topic is maps and GIS in geography. Before we get into our maps and GIS, and before we actually take a look at a past paper to give you an idea of how your examiner might ask some questions about it, we need to have an understanding of our revision and to know what it is that is a GIS and how we can use it in the real world. Let's take a look at our checklist.